All right, so like I was saying, today is dedicated to an ellipse. Last class, you guys learned about circles, and we mainly work with the standard equation of a circle, which is right here. X minus h squared plus y minus k squared equals r squared. Now, funny, you see the standard equation of an ellipse? It's really blurry here for me. But notice that they are very similar. A circle equation and an elliptic equation are extremely similar. There are two differences. One is that we have two fractions, right? And we also have the ellipse set equal to 1. Ellipse will always in standard form be equal to 1. So looking at the middle column and the rightmost column, you notice there are actually two different types of ellipses. There's a horizontal ellipse and a vertical ellipse. And we have linked here to videos if you want some extra info on ellipses. You can go and watch those videos. You don't really need it. It's just if you're curious. Now, if we're looking at the middle column, the horizontal ellipse, notice that the longer axis is on the horizontal. So if I'm looking at the long line, the longer line, this is called our major axis. The long axis is always called our major axis. When the major axis is horizontal, it's a horizontal line. When the major axis is vertical, so when the longer axis is vertical, it is a vertical ellipse. Now, if I'm looking at this horizontal ellipse right, there's a couple of variables. The length from the center of the ellipse to the edge of the ellipse along the major axis is A, where A is called the semi-major axis. Semi meaning half. So A is half of the major axis. The length from the center to the edge of the minor axis is your B value. And they call this the semi-minor axis. These letters are important because they are what you divide by in your standard equation. Notice H and K still represents our center. Also, a couple more vocab words here. The end point of the major axis is called a vertex. So we have two vertices. Vertices is the vertex. And if you look at the end points on the minor axis, these are called your covertices or covert. To find these points, all you have to do is take, so if I'm looking at the vertex, you take your H value and you add A to it. And then the K value remains the same. To get the other vertex, you subtract A from H. To get your co-vertices, the H is the same, but you add and subtract B from K. Do you need to memorize? No, you can always have this little cheat sheet handy. It explicitly defines these right here. To find the vertices, this is what you do. To find the covertices, this is what you do. Last thing we need to go over is the foci. So I just learned that this word here is pronounced foci. I thought, oh my God, everyone I've ever known has said foci because it's the plural of focus. So I'm like, okay, the plural of focus has to be foci. Well, no, it's foci. Isn't that weird? I thought it was really weird. I just learned it today. Um, we need to know how to find the foci. If I'm looking at this diagram right here, these 2 points represent the foci. And the distance between the center and the foci is defined as C. Yes, indeed. Zane says yes, indeed. To find the length of C, because they won't give it to you. Well, sometimes they will. Most times they will. To find the length of C, we need to use this formula down here. If we take the semi-major axis and we subtract square, and we subtract the semi-minor axis square, we get the C length squared. So to solve, we're just doing the square root of a squared minus b squared. And if we have a horizontal ellipse, we're taking that C and adding it to the H and subtracting it to the H to get the coordinate, oh my God, coordinate. If your ellipse is vertical, you're taking the C and adding and subtracting it from the K value to get your. And lastly, I just wanted you guys to notice, looking at the horizontal ellipse, all of its attributes, and then looking at the vertical ellipse's attributes. The only difference is the semi-major axis is underneath the x value when it's horizontal, versus when it's vertical, it's under the y value in your standard equation. This is what determines whether or not it's horizontal or vertical. Whether or not the bigger number is under the x or the bigger number is under the y. Okay. So I know that that was all just a ton of information. And I know the majority of you probably didn't absorb it. Probably a third of the way through, you kind of zoned out. It's just like she's saying all of these words, and I'm just writing it down, but I don't know what she's saying. That's fine. I the exact same way. I need to look at an example, or I need my teacher to show me an example before I understand anything. Some people can learn that way. Some people can hear things and just boom understand them. I never work that way. So let's go ahead and actually apply this to a graphing problem. Right here. We're trying to graph this ellipse. Now, the numerator on these fractions is extremely similar to a circle, right? And it behaves the same as a circle in that this is where you find the h and k value. So if I'm looking at my numerators, x plus 4 squared, y minus 2 squared, what is my h value? Yes, good, Jack. You look at the number after the X, and remember, it's opposite from that number. So instead of saying that H is a positive 4, H is actually negative 4. And what about the K value? What's our K value? Yes, remember, it's again the opposite after the Y. So instead of writing negative 2 for our K, say positive 2. And A and K determine our center point, just like it did for the circle. So I can plot the point negative 4, 2. That's my center. Now looking at this standard equation, what is your value? Yes. Oh, Serena got it. Yes. You're close, Jack, but you needed to do something for here. Because remember, looking at our equation in standard form, our fraction is divided by a squared root. Right. So this 3 does not define A, it defines a squared. So to get the x value, we actually have to square root the 36, and we get 6. Now, did you just willy-nilly pick 36 as the a squared value? I hope that you knew. Okay, I know that that's the a value because it's the bigger number. And then what's our b value? Yes, there it is. Yes, guys, exactly. B squared is equal to 25. So we square root 25. So we know that our major axis um, has a distance of 12 because it's double the semi-major axis. Okay, also, is this going to be a horizontal or a vertical ellipse? Yes, yes, I think it's going to be horizontal because a bigger number was under the x value. So I'm going to go ahead and start drawing because I actually have everything I need to graph this ellipse already. I know that my semi-major axis is 6, and it's horizontal. It's a horizontal ellipse. So from my center, I'm going to count 6 left and right. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. Meaning my vertices are located at 2, 2 and negative 10, 2. I also know that my semi-minor axis is 5. So from my center to get my co-vertices, I just count up and down 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And I have successfully graphed a major point on this ellipse. I can connect them. And I have poorly drawn ellipse. And my oh sorry, I skipped this part. My co-vertices are at the 4, should do this in green, negative 4, comma, what is that? And negative 4, negative 3. And I already actually have identified my semi-major axis as, and my semi-minor axis as 5. Remember, semi-major Is A semi-linear? Is B semi meaning and last but not least, you actually, whenever you're being told to graph an ellipse, it's not required that you graph the foci, but I'm just going to graph them here just so I can see exactly what I'm trying to find. So I'm trying to find the foci, but in order to know the foci's coordinates, what do I need to solve for first? C, good. And remember, we can find C by using the formula a squared minus b squared, where a is 6 and b is 5. And 6 squared is 36 minus 25, which is equal to square root of 11. And yes, they are going to want you to write in terms of simple stratical form. Now looking at the ellipse, we know, or hopefully, we know that the foci are always on the major axis, in line with the center. So I know, knowing that my foci is on this major axis here, that's the major axis. This is the minor axis. Knowing the foci are on the major axis, am I going to keep the H value or the K value the same for the foci as the center? Which one will remain the same, the H or the K in this case? Is it going to have the same X or Y value as the center? Yes, yes, Elise. It's going to have the same Y value, right? If don't graph these because it's wrong, but if my foci are there, no matter what the X value is, the Y value is still going to be 2. It's on the major axis always have that Y value of 2, that 8, or sorry, K value of 2. So I leave the K value alone, and I'm taking my H value, which is -4, and adding and subtracting my C value of square root of 11, which the square root of 11 is about 3 1/3. Oh, so I got them pretty well. If you were wanting to graph them, I would do from the center over 3 1/3 and 3. Any questions on how we graph this? Okay, I'm going to do it one more time, and then we're going to move on to review completing the square that you did last. Okay, look at the equation. What is your center? We'll just jump right in and say, okay, what is your center point? Yes, you take your A and K, which is 1 and -3, and it gives you your center. What is your A value this time? Hmm, 7. We're split, completely split. Guys, this is one of the major issues that students have. They immediately in their head think, oh, the A is the first fraction. No, A is always your bigger denominator. So here, our bigger denominator is 9. That means A squared is equal to 49. So our A value is 7. And therefore, this 4 must be what B squared is equal to. So our B value is 2. Knowing this, is this a horizontal or vertical ellipse? Yeah, it's vertical because our A is actually in these, so this is, I, I keep saying that. I'm trying to switch. If I say second denominator, what I really mean is the A is under the Y term. When the A is under the Y term, this is what makes it ellipse. So I'm going to plot the center. We have 1, -3. And I'm also going to use my semi-major axis to find my vertices. So this is a vertical ellipse, meaning my vertices are going to be vertical from the center. So I'm going to count up and down 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. And my co-vertices are to the left 2 and to the right 2. If you get done graphing and you realize that your ellipse is not vertical, it just means that you graphed it the wrong way. And you need to switch. Wow, I cannot draw a. Oh, this is the last time. Whatever I just said. Oh, okay. So my vertices are located at 1, 4, and 1, -10. And my co-vertices are -1, -3, and 3, -. My semi-major is determined by my A, and my semi-minor is my B. And last but not least, I have to find my foci by first solving for this C value by doing the root of your A squared minus B squared. 7 squared is 49. 2 squared is 4. 49 minus 4 is 45. Is this in simplest radical form? No, it's not. Remember, to get it in simplest radical form, basically what you're doing is you're pulling out perfect squares. What perfect square goes into 45? What's the largest perfect square that goes into 45? 9, right. So you pull the 9 out by square rooting 9, and you get 3. 9 times 5 is 45, so you're left with a 5. Oh my gosh, you're left with a 5 on the answer. Now, remember, our foci are on our major axis. So, are my H values or my K values going to be the same this time? Which one's going to remain the same? H, right, yes. Your foci is going to have the same H value as the center. So I keep the H value the same, and this time I'm adding or subtracting the C from the K value. So 3 times the square root of 5 is very close to 7. It's 6.6, I believe. So these foci are way out there. They're very, very close to your vertices. This is what makes it so long. Any questions? Okay, so now let me ask, let me pause this. All right, so when we're trying to complete the square um, of anything that has multiple variables, what you first need to do is you need to group the variables. And you also need to take the constant and move it to the other side. So that's what I'm going to do first here. I'm going to group the x's and group the y's. So I have 5x squared minus 30x, and then I have y squared plus 72y. And I'm going to subtract 27 to the other side. Now, when you're trying to complete the square, you need to have your a term of the quadratic. Notice there are two quadratics here. One with the variable of x and one with the variable of y. You need your a term to be 1, meaning you need to pull the current a value out of the set of parentheses. Basically, you're dividing out into 2. So right here, the first thing I'm going to do is I'm going to pull the 5 out of both of these x terms. So I have 5 parentheses x squared, and then negative 30x divided by 5 is negative 6x. And I'm going to leave it space so that I can complete the square. And then I'm going to do the same thing for the y values. I'm going to pull out an 18. 72 divided by 18 is 4. And I'm going to leave it 6. Now, somebody tell me, and I'm sure without looking at your notes, just look at my notes, okay? Don't look at your notes. How do you find this number? What do you do? Yes, right. Divide what by 2? Divide what by 2? The b value, exactly. You take the b value, which in this case is negative 6, divided by 2 and square it. So negative 6 divided by 2 is 3. Negative 3 squared is a positive 9. Now, the difference from here to what we did with circle is that we are not just adding 9 to the right-hand side. Because we didn't just add in a 9 here. What did we actually add in? Yes, the 9 is being multiplied by that 5, actually. So we can't just say plus 9 over here because it's not just 9 that's being added in. It's 9 times 5. Or 45, you can run. Either one. Someone, I had never written it like this, but someone was like, oh, I just write it as literally the A value times the B over 2 squared value. And it kind of makes more sense in your head. Now, when you go back and look at this later on, you'll immediately remember, oh, that's right. We have to multiply it by the A value. But anyway, what then do I put in my second open plot for my Y values? Yes, you take your B value, which is 4, divide it by 2, and you get 2. You square it and get 4. But then we're not just going to write plus 4 here. We're going to write plus 18 times 4, which is 72. plus 45 plus negative 27 is actually 90. So this whole thing is equal to 90. Now the next step has us actually completing the square. How do I write this as a binomial square? Right, yes, yes, yes. You write an x, and then you take your b value, and you divide it by 2, and write it down. And you have successfully completed the square. Then here, do the exact same thing. Write a y, whoops, write a y, and then take your b value, divide it by 2, and you have again completed the square. Now we have an issue here because this is not actually in standard form yet. It's not equal to 1, and a or b values yet. What can we do to make this equation be equal to 1 instead of 90? Yes, Jack, and I know. That's what you've never been taught it, but she told you this last class. In order to set this equal to 1, all you have to do is divide everything by 90. So 90 divided by 90 is 1, which is what I wanted. 5 over 90 actually simplifies to a denominator of 18. And 18 over 90 simplifies to a denominator of 5. And you're done. You have found the standard form of this ellipse. And we now can easily identify the center is at 3, negative 2. The a value is the square root of 18, which is actually 2. Whoa, no. 3 square root of 2. And the b value is the square root of 5. So this is why we complete the square, because we want to know where's the center, where's the what is the a, what is the b. Are there any questions on this completing the square?